Hey guys, so today we're going to go over word problems for systems of equations. Skip over to the classwork, skip that warm-up, we'll save it for another time, and write down these steps for solving word problems. If you need to pause the video and write them down, you can. So the steps involve, first, reading the problem, of course. Second, defining your variables, which usually happens at the end of the problem. You can underline the last sentence, and that usually gives you your variables. You're going to write your system with two variables and two equations. You're going to either choose elimination or substitution to solve. You'll solve for x and y, and you'll answer the question. So let's repeat those steps with this problem. The length of a rectangle is 4 more than twice the width. Okay. The perimeter of the rectangle is 26 inches. Write and solve an equation and solve to determine the length and the width of the rectangle. So we've read the problem. Now we define the variables based off of the last sentence. So it says determine the length and width. That means I need a variable for both of those. So let's let L equal the length, and we'll let W equal the width. You need two variables here because it's a system. Two equations, two variables. We're now going to label our rectangle with length and width. Let's switch those up. And we'll write an equation based off of the information. So we're going to translate the first sentence. The length of a rectangle is 4 more than twice the width. The length is, that means, remember, is in math means equal. So we're going to start the first equation by writing L is equal to 4 more than twice the width. Twice the width is 2W, 2 times W. And 4 more than that would be plus 4. Your second equation is about perimeter. Now we know perimeter is adding up all the sides and lengths of the rectangle. So we can add W plus W plus L plus L. And that gives us 2 twice W plus twice the length. And it equals the perimeter, which is 26 inches. Now we have a system of equations where we can solve for the actual width and the length. So I would like you to pause the video, and since one of the variables is alone, use substitution to plug in what L equals into the L of the second equation. So we've done 1 and 2, we've written a system, we've decided to use substitution, and now you guys are solving and even try to answer the question. Alrighty, so when you did substitution, you plugged 2W in for L, and you should have solved and gotten W equals 3. And when you plug 3 back into your cloud, you get L is equal to 10. So our final answer here is that the width is 3, and make sure you label it with the dimensions, inches, and the length is 10 inches. All right. We're going to skip number 1 for now. We'll use it as a warm-up. And we are going to do number 4. Skip a couple of those. So number 4. A drama club earns $1,040 from a production. A total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as the student ticket. Write and solve a system of linear equations that represents the situation. What's the price of each type of ticket? There's your question again. There's our variables. So step 1, we read the problem. Step 2, we're writing the variables. The price of each ticket is what we're looking for. So my variable will say, let X equal adult tickets, price, so put somewhere in that it's the price, adult price, and let y equal the student cost per ticket. Now we use what we highlighted to write equations down. They're earning $1,040 from a production. There's a total of 64 adult tickets and 132 student tickets that are sold. So we multiply the number of adult tickets sold times the cost. So let's match this up. 64 adult tickets times X, the cost per ticket. So I'm going to start that off. 64 times X plus 132 students times the cost per ticket Y. So plus 132 Y. And now we need a second equation. Sorry, let's just set that equal to the total, which is 1,040. The second equation deals with the second statement. Adult tickets cost twice as much as the student ticket. So the adult ticket is X. So let's let X equal twice the student ticket, 2 times Y. And now we can solve this system. So now we need to decide substitution or elimination. In this problem, you already have a variable alone. The X in the second equation is alone and equal to 2Y. So cloud that up and plug it in to the X of the first equation to apply substitution. You can pause the video and try that on your own. Alright, so now you should have gotten Y equals 4 and X equals 8 for your answer. So when you go back and answer the question, we go back to our defined variables. X was adult cost, so I'm going to say that the adult tickets cost $8. Adult tickets, you can even put a semicolon, $8. And the student tickets is my Y value, and they cost $4. And that's your final answer. Alrighty, we're going to leave some of this worksheet for class, so let's go ahead and do one more. In this video, we're going to go over the salesman rents problem. That's problem number 11. Okay, so a salesman rents a car for 2 trips from the same car rental company. The rental company charges a daily fee plus a charge for each mile driven. Write and solve a system of equations to determine how much the rental company was charging per day and per mile. So here's our question again. Charges per day and charges per mile is what we're looking for. So let's let X equal the charge per day, or you can put a cost per day, and we'll let Y equal the cost, or you can put a $sign, per mile. And we basically use the chart, which is nicely set up for us to make our 2 equations. Let's start with the first trip. The first trip is 4 days, so X is cost per day, and 120 miles. So Y is our cost per mile. So we attach the variable to the number of days. So 4 days times whatever the cost is X, plus 120 miles times whatever the cost is per mile, Y. And that total first trip costs $252. Go ahead and pause the video and write your second equation. If you wrote it down already, your second equation should be the 7 days times the cost plus the 180 miles times the cost equals the total for 23. Now notice, this equation is set up for elimination because my X's are lined up and my Y's are lined up. You can choose substitution if you're more comfortable with that, or we can solve this with elimination. I'm going to walk you guys through the elimination for this problem because we're going to have to change both equations. Remember that when we look at a variable to eliminate, we want to choose the numbers that are easier to work with. And maybe if they're already opposites or one of them's already a multiple, it helps us. In this case, we're looking to find the least common multiple of 4 and 7, which in this case is 28. Now I need a multiple that's positive 28 and a multiple that's negative 28. That way, we can cancel or eliminate that variable. I'm going to move this over real quick so I have some more space. Put it up here. Whoops. And now let's start the elimination process. In order to get a negative 28 in either the first or second equation you choose, you have to multiply by a negative number. So to make this 4 negative 28, I'm going to multiply the entire equation by negative 7. And to get the second equation to be a positive 28, I'm going to multiply by positive 4. So my two new equations are going to read every single term multiplied by those numbers. Let me just fix this one. So pause the video and write out what the two new equations will be. All right, so here are your two new equations. You want to add downwards, so negative 28 plus 28 will cancel. Negative 840 plus 720 will give us negative 120. I know they're big numbers, but they will give you an accurate answer. And then 1764 plus 1692 will give us, and again, I'm using a calculator here. You guys should and can be doing the same thing. 1692 plus negative 1764 will give us negative 72. And our last step here is to divide both sides by 120, and you will get a positive 0.6. Go back to the variable we defined. That y is the cost per mile, so I know it's 60 cents or 0.6 cents per mile. You could have also written that as this. I would have been okay with that. Put a $0.60. Regardless, either way works. Just make sure that you plug 0.6 in to one of your equations. I'm going to use the first one for y and find out what x is. So pause the video and try. Right, so you should have gotten x equals 45 when you plugged 0.6 in. Be careful here because we said 60 cents because this was a decimal. This is referring to dollars. So we know per day, because x was the cost per day, it will cost $45. And that's your final answer here. We will continue working on these problems in class together. So I just wanted to do a couple for the video because I know they're lengthy, and we'll do a couple more together in class. Right?